right, let's see what we're looking at here. Okay. What's the answer to 1?
For solving a system. Dividing? Would that be one?
No, elimination and substitution.
Oh.
Okay.
Okay.
We'll do elimination with number 3. But that's your 2 primary means of solving a system of 2 equations. Or 3. If you had 3 equations and 3 variables, you would still have 2 methods. You could either use substitution or elimination.
Okay.
Actually, a third method that is graphic. Okay.
Oh, wait. Bless you. Bless you.
Thank you, but you say that, you're going to end up saying bless you about 20 times here today.
Okay.
Give me a second. Let me go get a Claritin. Hold on. I hope it's allergy. Either allergies or a cold, and the cold will last for 5 days. Allergies will be gone by tomorrow. Sometimes it's hard to tell the difference. It's hard to get into your allergy tablet. Currently having a hard time doing. All right, hold on. All right, number 2. Let's say I said following. Yeah. If I said y equals 2x plus 1 and y equals 4x minus 3, if I can graph both of those, wherever they cross is the solution. Okay? Well, if I graph the first one, a line like that. If I graph the second one, it's a line like that. Well, that point is your x and y solution. And that's true whether you're dealing with linear equations or parabolas or most anything. In other words, if I had a parabola and I wanted to know the solution between a parabola and a straight line, it's these 2 points. And each point has an x and y coordinate. So that is actually the third method for solving a system graphically. It's not a particularly good method, as you can kind of see, because your answers aren't going to be real precise.
Yeah.
If you used a straight edge, it's hard to draw a perfect parabola. If I just had 2 straight lines, not so hard. Then you just use a straight edge and you can figure out where they cross if you had a straight edge. Okay? Graphing is not the best way to do it for obvious reasons. It's hard to see the answer exactly. So, for problem 3A, which of our methods are we going to use? We have substitution and elimination. Or you can use one of them, you got to recognize where you're going to use it. What am I going to use on 3A?
elimination.
Yeah, and you use elimination whenever it's in standard format. Use substitution whenever there's one equation fully defined. Notice that neither of these equations is defined for a variable. Both of them are in standard format. So we're definitely going to use elimination. On 4a, notice that the first function is fully defined in terms of y. So is the second one. So all I got to do is this one I'm going to use substitution on. So that's what determines what you use, is what form they're giving you the equations in.
Okay.
Now, let's talk about elimination, number 3. I'm going to call that equation 1 and that equation 2. Now, the idea is to add the two equations or subtract them. You can do either one. Either one of them is allowed. And in the process, eliminate a variable. Well, I can't eliminate a variable as long as they're in this format.
All right.
What if I took equation number 2 and changed it? Instead of being the way it is, I'm going to multiply both sides by, what if we took equation 1 and changed it? And I'm going to change it by multiplying both sides by -2. I'm going to multiply that side by -2. I'm going to multiply that side by -2. What does that give me? That gives me minus 6x plus 2y equals minus 18. And just for the sake of having the same size, I'm going to rewrite equation 2. I'm not going to change it. Equation 2 stays exactly the same. Now notice, I cross those out because those are no longer the ones I'm working with. How can I eliminate a variable? By doing what?
Adding
Okay.
or subtracting.
Yep. No, you can either add or subtract. But I'm not going to eliminate a variable if I subtract. If I add these two equations, the y's will go away. So what am I left with?
Negative 5x equals negative 20.
X equals?
4.
All right. Now, I still got to solve for y. Okay. And to solve for y, you want to go to the easiest equation that you had. Of the 4 that I had written, the easiest is always going to be one of the original ones. Okay? So which one are you going to use to solve for y?
The second one.
Okay? So do it. If x equals 4. Tell me what to write.
4x.
No.
No, yeah, 4.
Just 4. X equals 4.
Minus 2y equals negative 2.
Keep going.
So subtract 4 from both sides. So
yeah, just read the next line to
me. So negative 2y.
Negative 2y.
Equals 2.
No, you're subtracting 4 from each side.
Negative 6 then.
What's y equal now?
3.
Okay. So there's our solution. We got it algebraically by using elimination. And now we're going to graph it. Well, relatively easy way to graph an equation that's in standard format. Not the typical way. The typical way is you solve it for y and you graph it as if it were in y equal mx plus b format. I'm going to show you a different way of doing it.
Okay.
Let's find of this equation right there, let's find the y-intercept. What is it? What's x equal to when you're talking about the y-intercept?
0.
Okay, plug in 0 for x and solve for y.
So it's -9.
Okay, that's my y-intercept. Now solve for the x-intercept. What's y when we're talking about the x-intercept?
0.
Plug in 0 for y and solve for x.
-2.
Plug in 0 for y.
Oh, it's still the first one. Oops. So, 3.
Okay. That's the x-intercept. Now I can graph that. Notice that I didn't have to worry about slope. Not once did I worry about slope. Because all I did was I graphed 2 points, the x and the y-intercepts. Now do the same thing for this one. Figure your x and y-intercepts. I'll do that in blue. What are your y? What's your x-intercept? That's the easy one.
-2.
What's the y-intercept?
1.
Draw a straight line through those 2 points. Again, did not have to worry about slope. Look what I got. Now, notice that our algebraic answer was x equal 4, y equal 3. I probably would have got that if I'd have used a straight edge. But I'm a little off. I got my x equal 5, y equal 4. In other words, according to the graph, x equals 5, y equal 4. It's whatever the x and y coordinate is of that point. And this just shows you that the graphing method isn't real accurate. Now, had I used a straight edge, I'd have probably been on that grid, the grid at 4, 3. But not a method I particularly like, the graphing method. But they tell you to do it that way. So in other words, they want us to do it algebraically and graphically. Now, do this one. Algebraic first. Notice these are not in standard format. They are in the format where we're going to use substitution. The moment I see even one, both of them don't have to. One could be in standard format and the other could be solved for y, and I would use substitution. I always use substitution if one of my equations is fully solved for one variable, and it doesn't matter which one. It could be x would be fully solved. In equation 1, y is fully solved. Okay? And in fact, in equation 2, y is fully solved. And since those are both, we are in a system, which means those two y's are equal to one another. So how do I solve this? There's a real easy way.
Okay.
If the y's are equal to one another, then what else is equal to one another?
the answers or solutions.
The left side of these two equations are equal to one another. Therefore, the right side are equal to one another.
Okay.
Remember, that's the same y. They're not different y's. They're both the same y because we're talking about a system of equations. Y is always y. Okay? Now, solve that. That's a single equation, single variable. Pretty easy to solve. Go ahead and solve it.
Okay, so subtract 4 from both sides.
Okay, give me the next line. I'll let you figure out how to do it. Just read the next line always to me. I'm going to assume by this point you know how to solve a simple equation. But prove it to me by telling me the next line.
X equals negative 2x plus 3.
Next line.
In
other words, I haven't solved for x. Looks like I have because I have x over here all by itself on the left, but I still got an x over on the right. I haven't solved for x until I get x equals a number.
So then 3x equals 3.
And x equals... What's y equal to? Which equation are you going to plug it into?
The first one. So it's 7.
It's 1 plus 4.
Oh, oops. 5. For some reason, I was thinking it was 3.
Okay. So that's the solution. Now let's see if we can come a little closer on our graph. Well, it's fairly easy to graph both of these lines, right? They're in y equal mx plus b format. You know how to graph that. We start with the b, apply a slope to get a second point, connect the two lines. So the number one equation, where do I start?
So
Graph y equal x plus 4.
all right. So so at 4.
What's the y-intercept? You always start with the y-intercept.
Oh, 5.
That's b. This
So 4,
down here is the solution to both of these equations.
Are you done?
Okay?
Yeah.
But if we're going to find it graphically, you have to graph each one separately. So graph the first one.
Yeah.
I'll graph the first one in blue. I'll graph the second one in pink. Wherever they cross should be at x equal 1, y equal 5. But how do I graph that first one?
So since the y-intercept is 4,
1 point.
so 4. And
what's the slope?
Up 1 over 1.
Or up 2 over 2, just to give myself a little distance between the 2 points so that I can draw a little more accurate straight line. Okay. Now graph the second one. Where do I start?
So the y-intercept is 7.
Second point.
So down 2 over 1.
Yeah, that's right there. Now that makes it easy to read the solution. Our solution came out exactly where it should, at x equal 1, y equal 5. So graphically gave us the same solution.
Okay.
I know the trash can guy's names now.
Hold on one second, Demetrius. My Windows Ink workspace is acting up on me. There we go. When you are solving a word problem, always start by defining your variables. And you don't do that by the beginning of the problem. You do it by reading the last sentence. What are they asking for? From that last sentence, define 2 variables for me and tell me what each one of them means.
So x is the amount of cars.
X equal the number of toy cars. And it's important to define it exactly because we're not talking about the price of toy cars. We're talking about the number of cars you sell. What's Y?
The number of toy trucks.
And notice the problem does have prices in there. So we got to be very specific as to how we define our variables. Now, convert that to an equation.
Okay, so 0.25.
Hold on, not yet. The one I underlined. Convert that to an equation. There's going to be 2 equations. We'll get to the second one. Let's just take them in order. In other words, we don't work from backwards. We start at the back to define our variables, then we go to the front.
Okay. So, bless you. Bless you.
I guess the only thing you can be pleased about is that we're not in an in-person session, huh?
Yeah.
I'd have to cancel. I wouldn't want to inflict my germs on anybody.
Okay. So
first equation.
30xy.
What is it? If x is the number of toy cars and y is the number of toy trucks, and it says I have 30 total, then give me an equation that says what that sentence says.
X plus y equals 30.
Now the second sentence.
So
it's got $12 to spend.
So 0.25x plus 0.5 y equals 12.
Yeah. In other words, that's going to be his cost for all of his toy cars. That's going to be his cost for all of his toy trucks. Add them together, he's got 12. Now notice that I have 2 equations, 2 unknowns, and they're both in standard format. What method am I going to use to solve?
Elimination.
Okay. How do I eliminate a variable? What do I got to do? Call this equation 1, this equation 2. At the moment, I cannot eliminate a variable. Remember, I can only do one of two things. I can add these two equations or I can subtract them.
Okay.
If I add them or subtract them right now, a variable will not be eliminated.
Right.
What can I do to one of these equations? What can I multiply this bottom equation by so that I can then eliminate? Come up with a new equation 2. What do I have to multiply it by?
0.25.
How many quarters in a dollar?
4.
So if I multiply the second one by 4, that'll turn that into x. So let's do that. Okay? So that's x plus 2y equals 48. That's my new equation 2. Now, can I eliminate a variable?
Yes.
By doing what? Adding or subtracting?
Subtracting.
Okay, let's subtract 2 from 1. In fact, let's subtract 1 from 2. Notice why that's slightly better. X is still going to go away. It doesn't matter which way I do it. But subtracting 1 from 2 is going to give me nothing but positive coefficients, not negative coefficients, which is where I'm headed right now. So what is equation 2 minus equation 1 equal?
So y equals 18.
There's your number of toy trucks he has. How many toy cars does he have?
12.
There's your answer. These word problems are extremely easy as long as you start them out right. If you don't start them out right, they are a bugaboo because you get completely confused. Everybody does. Gets completely confused about the difference between the number of toy trucks and cars and the price of each one of them. And you have to deal with both of them here.
Right.
Okay, how about this one? Write a system of equations, then solve the system. So go to the last sentence. You don't even need to read the rest of it yet. Just go straight to the last sentence. What are they asking for?
How many of each type?
Okay, so we're going to let x be what?
The lower level seats.
Two types of seats. There's lower level and there's upper level. So lower level seats, number of lower level seats. What's the other variable going to equal?
The upper number of upper level seats.
Okay. Now we have our variables defined. Start giving me some equations. Starting with the first sentence.
So there are 500 seats total.
Give me an equation, not a sentence.
X plus Y equals 500.
Huh? That takes care of that. Now, based on the second sentence, give me another equation. Actually, the next two sentences. Got to go all the way down to there to get to the full equation.
So
It's the total price you get for all the lower level seats.
oh, $92. So 92 Y X.
It's 92 times X. That's the total amount you're going to get for all the lower level seats. If there are 100 lower level seats in the place, you're going to get $9,200 if you sell them all. So it's always the price times the number of seats. What's the second part?
87Y.
Equals?
44,500.
What method are we going to use to solve this system of equations? Substitution or elimination?
Elimination.
How am I going to do it?
Multiply the top.
Equation 2, go ahead.
Multiply the top one by 92.
Okay, that works. 92, 92. In your calculator, multiply 92 by 500.
Uh, 46,000.
Now what? That's a 92 in front of the y. Now, how do you eliminate a variable?
Subtract it. Subtract the bottom from the top one.
Okay, do it.
So, 5y equals 40. Oh wait, no, never mind. 3,000.
1,500. 46,000 minus 44,500 is 1,500.
Oh, okay.
So what's y?
300.
And what's x?
200.
Okay. That's the way you do those. You start at the back, you start there, then you go there, then you go there. Every time. Always start at the last sentence to define your variables, and it's real simple because they always make it real simple. They ask a real simple question. How many of each type of seat? That means there's two types of seats, and we have to label X as one of them and Y as the other. Or how many toy cars and toy trucks? X is toy cars, Y is toy trucks. Right. Is there a second page or is this it?
I didn't take a picture of the second page. I'll real quickly take a picture of it and then send it to you.
Okay.
Okay.
All right. See if I got it here. Yet. Did it say file sent?
Yeah.
You send it to David Cowan 1949
Yeah.
gmail.com.
Yep.
Everything's running a little slow today, I notice. Windows also. Okay. If we make the horizontal scale the time scale, which you always do, that's always the horizontal scale. So if this is time here, this is charge or price. Okay, total charge.
Okay.
He charges $4 to rent a bike plus $2 per hour. How do I graph that? What's that graph look like? What's he get when time is 0?
It's high. It starts higher up.
What would he get at 0 if the guy rented it and didn't use it at all? You get $4.
Yeah, $4.
Well, that's the Y-intercept is at 4. The 2 for each hour is the slope. So if I go up 4, now let's see, let's go up 1 and, excuse me, let's go up 2 over 1. So
Okay.
that's a graph of his situation. Notice that if I'm at 1 hour, I'm going to get 4 plus 2, or that would be at 6. If I'm at 2 hours, I'm going to get 4 plus 4, or 8. So this is a linear model, meaning that we're going to graph it with a straight line. And the Y-intercept is usually your base charge. Okay? That's for a regular bike. A two-wheel bike is $8 plus $1.50 per hour. How do I graph that? In blue.
So it should start up at 8.
Mm-hmm.
And then go up 1.5 and over 1.
Good. Or up 3 over 2. Same thing. In other words, it's not as steep as this red line. This red line had a slope of 2. This has a slope of 1.5. So it's kind of like this. Now, when will the two companies' costs be the same, and how much will the cost be? Well, graphically, we can see there's our solution, right?
Right.
In other words, the cost, this should say total cost, not total charge. Okay? The Y value is the total charge. Well, they're equal when these two are the same, which is where I've put it up there. They want some numbers, and I can't accurately get numbers from the graph. So they wanted us to graph it, But to solve it, I really need to do it algebraically. So tell me how to begin. Forget the last sentence and go to the last sentence.
Okay, so
What's the equation of the pink line? Y equal what?
X.
4 plus 2x. If x is the number of two-wheel bikes, here, let me start this over again. I don't want to violate what I said. Our first step is to define our variables. Okay?
Okay.
X is going to be the number of
the bikes, charge for bikes.
Hold on, I'm rereading the company. B-Cycle, bike rental company, charges that and that. Two-wheel field bike rental company. Okay, so X is going to be the number of hours for B-Cycle. What's Y going to be?
The number of hours for.
Not the number of hours, the total cost.
Oh.
In other words, because that question's asking about the costs, then Y, if you look at my vertical axis, that's the cost. So total cost for B-Cycle.
Okay.
Okay, now give me an equation for the red line. Y equals what?
So actually, real quick, I need to use the restroom. Is that okay?
Sure. Yeah.
I'll be right back.
Okay, no problem.
Okay.
All right. This problem's a little different than the previous one. The previous problem, we had two variables that were different, and we ended up with two formulas in standard format. This one's going to be a little different, because all we need is the equation of the red line. In this format, y equal mx plus b. What's the slope of the red line?
Up 2 over 1.
What's b?
4.
There's the equation of the red line. Now, give me the equation of the blue line.
Uh, 1.5x plus 8.
Plus 6, the y-intercept. Right? Oh, it was 8. Excuse me. That's 8. I had to reread the problem. Okay. Now, the question says, when will the two companies' cost be the same? Well, the bicycle company's cost is that y. The two-wheel field bike rental company is the blue y. And they're saying, when are they the same? That's the same as saying, when is 2x plus 4 equal to 1.5x plus 8? In other words, I'm going to set the y's equal to one another. These are actually two different y's. These are not, this y is not the same as that y, except in the context of their question. When will the two companies' costs be the same? That makes them the same. That makes this y equal to this y. Now, solve that.
So, first subtract 4.
Okay. Why don't you do both of them at once? Subtract 4 from each side and subtract 1.5x. In other words, when I see this equation, I say to myself, I got to move all the x's to one side, all the numbers to the other. I want to move the x's to a side that leaves their coefficient positive. So which way am I moving the x's?
To the left.
Which makes me move the numbers to the right. So let's do it in one step. Subtract 1.5x from both sides.
So that's 0.5x.
And subtract 4 from both sides.
It's 4.
Okay. Now what? What's that?
Divide by 1.5. So,
Not 1.5.
or I meant 0.5. Sorry. So that's 2.
Actually 8.
Oh.
Notice what this is. This is x. When I say 0.5x, that's the same as 1/2 x, which is the same as x over 2. So I really could write that as x over 2. And now you can see you got to multiply both sides by 2.
Oh, yeah, okay.
Okay. So x equals 8. Now tell me, what will the cost of the rental be if x is equal to 8? What will y be?
So 20.
And it's 20 in both cases. It's 20 for the first equation, and it's 20 for the second. And it better be, because we set those two y's equal to one another. So if they're not both the same number, then we've done something wrong. So the answer is at the end of 8 hours. In other words, remember what x is, the number of hours that I rented it from B-cycle. So x is 8, and the total rental is 8 times 2 plus the original 4.
Okay.
All right. Okay, this is a linear programming problem, which is fine. Basically, just going to tell you how to do it, as I can write on this thing. Gosh, I'm going to have to reboot my computer before I do my next session. It doesn't like me using this. All right. We have a feasible region over here that's in gray. And we have an objective function that is f of, and what that means is we have a function where we're going to have both x and y on the other side. There's our objective function. And that's what it's called. Okay? If I want to figure out the maximum and minimum, then I have to examine those vertices, all of them, all 5 of them.
Okay.
And plugging in the x and y values into this objective function, and whichever my biggest number is, that's the maximum. Whichever my smallest number is, that's the minimum. So let's number these points. 1, 2, 3, 4, 5. I can't read the values on here. Can you?
Yeah.
I'll do from my page, but if you've got the page in front of you, that looks like what? 4, 4?
Yes.
Okay, plug that in. So here's what we're going to do. F of 4, 4, that's 0.1, right?
Right.
What's that equal to?
Should I multiply it out or just put 4 in for both x?
4 for x and 4 for y, multiply it out, come up with a number.
So,
do you have a calculator in front of you? This should be real easy. 8 times 4 plus 12 times 4. Add the two numbers.
so 71.
You don't have a calculator in front of you, do you?
Nope.
Okay. 8 times 4 is 32. 12 times 4 is 48. 32 and 48 are 80. Okay?
Yeah.
For point 2, we're going to figure out f of, what are those two values? It looks like 8, 12.
Yes.
Can you get a calculator?
Yeah.
Hold on. We don't have enough time for you to go around and get a calculator. Let me use this calculator that I have. So 8 times 8, so that's 64, plus 12 times 12, 144, that is 208. So that's point 2. What's point 3?
12, 14.
Is that what those two numbers are?
Yes.
Okay, if I plug in 8 times 12, I get 96, plus 14 times 12, 14 times 12 equals 168. Add those together, and I get 264. Point 4. F of what?
14 and 4.
14 times 8. 14 times 8, 112. Plus 4 times 12 is 48. That's 160.5. F of what?
12, 2.
96 plus 24, 120. Now, tell me the minimum and the maximum.
So the minimum point is 80, so 0.1.
Okay, so minimum equals 80. Maximum equals what?
Um, 264.
And your minimum and maximum are always going to be on one of these vertexes. Your minimum
Right.
and maximum is never going to be there. It's 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 going to be inside. It's going to be on one of the vertexes of whatever shape you've enclosed. It isn't always five-sided. Sometimes it's four-sided. Sometimes it's three-sided. Sometimes it's six-sided. So the number of vertexes you have will change. But what you do is you get the points at each vertex and you plug it into your objective function. That gives you, in our case, 5 different answers.
Okay.
I'm going to go. Let you go. I'll talk to you Thursday.
Okay. All right.